Okay, welcome back. Are there any questions? So before the break, we did 5 examples to illustrate the multiple regression analysis. Okay, so the most important thing is the output from the regression analysis. So you would be able to explain all of this. Okay, and we also did the SPSS, creating a scatter plot. So that is before the break. So those are the scatter plot. Next, we are going to fit equation using SPSS. Okay. This is example 7.6. Use this data, rating, test, and gender. So to use SPSS for equation, you go to analyze regression linear. The dependent variable is rating. And then independent variable has 2. One is test and the other is gender. Okay. There are several methods for multiple regression when you use SPSS. One is enter. We also have stepwise, remove, backward, forward. By default, it is enter. Okay. So let's just use the enter method. Okay. And then you click OK button. So you see the output would be similar to as Excel, very similar. Okay, so if you want to write down equation, you based on this coefficient table here, coefficient table. I'm just going to copy this. To my OneNote so that I can make a notation. Okay. Note here. So I did. So this is the output. Okay. To write down equation, you just use this 3 number here. Okay. So y equal to negative 1.956 plus 0.12 test. Test is my x1, or you could use the variable name test, and then negative 2.181, that is gender, and y is our rating. Okay, this model is significant because p-value smaller than alpha. P-value is significant. The overall model is significant. Okay, so this is using SPSS. Okay, using SPSS. Any questions? Okay, next one, I will explain multicollinearity. Multicollinearity. When we are doing multiple regression, we are saying we have many x, x1, x2, x3, x4, etc. Okay. If some of these x are related, this is what we don't hope. X1 relate to X2, or X2 relate to X3, or X1 relate to X3. But sometimes it do happen. The independent variables are related to each other. Okay, so that is how the concept multicollinearity comes out. Okay, it is the situation where independent variables are highly related to each other, That is multicollinearity. Okay, and how do we detect the independent variables are related to each other? We use variance inflation factor. Okay, the formula for variance inflation factor is 1 over 1 minus r squared. That is the formula. Okay. And if this value is very close to 1, it suggests multicollinearity is not a problem. Okay, so it suggests multicollinearity is not a problem. The reason is when VIF almost equal to 1, close to 1, R squared must be close to 0. Okay, so the multicollinearity is not a problem. That is this concept. Next, let's look at the example. Example 7.7. This example shows an annual newsprint consumption Y. This is a Y dependent variable. The number of newspapers in a city, that is X1. The logarithm of number of families in the city, that is X2. The logarithm of total retail sales in the city is X3. So we have 1Y, 3X. Those data are collected for 15 cities. Okay. The question asks you analyze the output from the technology. So this question gives you the output, asks you to analyze this output. That is the question. Okay. So I'll try to make this bigger. So the question, the variable used is we have 1Y. Okay. And then we use X1, then log X2, log X3. So we use X1, but X2, we use log X2, and then log X3. Okay. And this is the output. And how do we interpret this output? Okay. So first, this is the correlations, okay, between X1, so papers, this papers is X1, and then log family is log X2. Log cells is log X3. So between X1 and log X2, the correlation is 0.6. Okay, moderate correlation. And then between log family, between log X2 and log X3, it is 0.9, very strong correlation. So these two variables are strongly related. Okay. And then based on this coefficient, we can write down the equation. So the newsprint, that is my Y, equal to B0, this is the constant, plus B1, X1, this is B1, X1, plus B2, X2 is actually not X2, is log X2. And then plus B3 is log X3. This is the equation. So this is B0, B1, B2, B3. Okay. And then we get the R square is 83%. Okay, adjusted R square 79%. And for the analysis of variance, we get a p-value. P-value. This p-value is significant. Okay, and this is MSE, MSR, MSE, SSR, SSE. Okay, degree of freedom. Okay, so that is the analysis. Because from the correlations we know log x2 relate to log x3, you in further analysis, but this is outside this topic, you could combine x2 and x3 together so that they only have 2x instead of 3x. The reason is x2 closely related to x3. Okay, so this is this example. Any questions? All right. So this is that's why this is two predictors. If you use two predictors, this is use three predictors. Use all 3x. Use x1, x2, x3. Okay. If you just use two predictors, 2x, you just use x1 and log. This is x3. Okay, you do not use this log family because log family related to log x3. So this is the result you get. Okay, so in this result, this module looks like significant. And based on the coefficient here, you can write down the equations. Okay. All right, so that is the, when you do the multiple regression, sometimes independent variables are related. You want to eliminate some variable, okay, or combine the variables. All right, so next example, 7.8 is about select the best regression equation. Sorry for the typo. It should be regression equation, not regress equation. Regression equation. Okay. So let's look at this question. So in this question, we have Y is my cells, aptitude test. Let me see, did I GPA, experience, anxiety, H? Yes, so this is aptitude test, okay? And this is the age. Age that have decimal, it is strange, maybe 22.1 years old, maybe 22 years and about 1 month, okay? So you can interpret that. This is the anxiety experience, GPA. Okay. The meaning of each variable. So this is a this example is a company want to say if employee, their aptitude test, the age, anxiety, experience, GPA is a high school GPA. If those factors contribute the sales, that is what we want to investigate, okay? Because we have many X, let's say X1, X2, X3, X4, X5. Okay, we have many X. We want to select the best regression equation, and we can use SPSS to do it, to select the best regression equation. Okay. So how do we do it? So go to SPSS. Maybe go to, I already have, I'll try to see if I have data in SPSS. Back. Okay. I'll try to open. You can just copy and paste the data into SPSS if you want. I want to check if I have the data available here. This data is chapter 7, example 8. Yeah, I have this one here. Chapter 7, no. Chapter 7, example 8. Chapter 7, example 8. I don't. So, okay, I can go to the Excel to copy the data, okay? This is this one. Yeah, so I have Excel data here. I'll just copy and paste to SPSS. So copy. File new. And then paste. So after that, change the variable. So the first one, what do I call it? Maybe I'll just call it Y. This one, maybe just X1, X2, X3, X4, X5. Okay. Okay, so I will ignore the decimals. I don't care about decimals. Okay. All right, so I have this one ready. I want to create a best model. I want to use SPSS to do it. So you go to Analyze, Regression. By the way, the best model only available in SPSS. You cannot do the best model using Excel. Okay. And then select Automatic Linear Model. Automatic Linear Model. In order to use automatic linear model, proper measurement is required. So SPSS need to scan data. So you just click scan data. Okay. After that, you have this. Okay. So the target variable, use custom field assignment. Click custom field assignment. So the target is my Y. Okay. Predictors is my 5X. So click X1, press and hold down Shift, press F5. You select all the 5 variables. Okay. And then click this button. Okay. After that, that is the field. After that, click the build options. And then select model selection. Okay. We want to select the best subset. You could select forward stepwise. Okay. So let's select best subset. Okay. After that, click the run button. Run button. Okay, now we have automatic linear model. This is a case summary. We have total 30 cases. Okay. We used actually information criteria. Our target variable is Y. Remember what is Y? Y represents the cells. Okay. So where is our model? You have to click this one here to see the, oops, not here. Okay. So this is our 5 predictors. 5 predictors. Okay. Out of these 5 predictors, which ones are important? So you go to next one. X2 and X1 are important. Those 2 variables are important. Remember what is X2? X2 is the age. X1 is the test score. Okay, so those 2 variables are important. Okay, and X3, X4, X5 are not important. So this is like the scatter predicted Y value. Okay, predicted value. And over here, we have the residues. Residues, because we have not large sample size, it's just 30, but the distribution is roughly normal. Okay. And we also have outliers from this output. Record 4 and record 14 are outliers by this output. And this one shows you the effects. So if remember, X1 and X2 are 2 important factors. Okay. And okay. This one you can get the coefficient of X1 and X2, as well as the intercept, the constant. Okay, the constant. If you click it, you get the number. Okay, so click it, you get the coefficient for X2, coefficient 5.93, X1 coefficient 0.2. Okay. So this is it is used visual representations. Okay. So the last table is a building summary, model building summary. As you can see here, we used information criteria. We use information criteria. So the smaller the number, the better the model. Okay. The computer actually ran try 10 different models, but only this model is the best model. And this model uses X1 and X2. The information criteria has the smallest value, 83. Okay, if you want to write down equation, you should go to here, get the B0. B0 is negative 83, B1 is 5.9, B2 is 0.2. Okay, so that is the best subset model. Any questions? Okay, so we did that. Try to locate my OneNote. It is here. Okay, so finally we get just X1 and X2. X1 and X2. We selected those 2 numbers. All right, so this is the best subset model. Next example, example 7.9 is the all possible regressions, all possible regressions. Okay. So this use the same example. Remember, we have 1y, we have x1, x2, x3, x4, x5, 5x. Okay. If you use just x1, if you use one variable, the choice are just use x1 or just use x2, just use x3, just use x4, just use x5. Okay, and you can run the regression and you can get the R-square value for those. You can get R-square. And then if you choose two variables, you can pick x1, x2, x1, x3, x1, x4, x1, x5, or you could pick x2, x3, x2, x4, x2, x5, or you can pick x3, x4, x3, x5, or x4, x5. So those are all possible combinations if you choose only two variables. You run the regression, and those are the R-squared. Okay, so if you pick three variables, you get those R-squared. If you pick four variables, those are the R-squared. Those are the all regression models. All regression models. But based on those regression models and based on R-squared criteria, the best regression model, this is next example. Those examples are connected, okay? Number are connected. So if you use select just one variable, this model is good because it produced the best R-squared. And those are two variable situations, 3 variable, 4 variable, 5 variable. And this 2 variable situation matched our best model criteria. We did best model first, right? But those are possible other models, right? All right, so this is this one. So based on this variable, we can write down this equation here. And I showed you B0, B1, B2. So this is, I did that best subset, okay. So far we did best subset, all possible models. So next one is the popular, another popular one, stepwise regression, stepwise regression. So for this one, we are going to use, again, using Excel, or not Excel. Excel will not produce stepwise. So we use SPSS. This is the steps, okay. So I'm going to go here. This is my data. I will save this, save as. This is my example. Example 7.8. So I will save in (703) my data. This example 7.8. And it is also an example 7.11. It's also 7.11. So use this data, we'll use stepwise. Okay, so go to analyze, regression, linear. y is my dependent variable. So I have 5x. Under the method, you select stepwise. Okay. And then you click OK button. So the principle behind the stepwise is that in step 1, it will choose just one variable, the most significant variable. And then in step 2, it will add another variable so that it has two variables. So keep on going until you found the best mode. It actually connected to the best mode, but this is the stepwise. Okay, so using stepwise, as we can see, we extracted two important variables, x1, x2. It is agree with our result from the best model. Okay, so those are the coefficients. Okay, so maybe I want to copy this to the notes. This is put the result here. And based on this stepwise, you can write down equation. See, we did, okay, you can write down equation based on these three values. You have constant B0, B1, and B2. Okay, so that is the stepwise multiple regression equation. I actually have this one. Any questions?
Can you redo how you did the stepwise?
Sure. The stepwise procedure, you go to analyze regression linear. Select y as dependent variable. x1, x2, x3, x4, x5. Those 5 is an independent variable. And then from method, you click stepwise. That's it.
Perfect. Thank you.
Okay. Thank you for your question. Any other questions? All right. So that concludes our chapter 7. Multiple regressions. Here I have the key terminology. Okay, what is dummy variable, multicollinearity, etc. Okay, read what is stepwise. Okay, and the key formulas here. Okay, we explained all those formulas from the output. Okay, adjusted R square. Okay, variable inflation factor. So there are many formulas in this chapter. Okay, so next we are going to go over some selected questions. Okay, as a review. Okay, so question 1, what are the characteristics of a good predictor variable? How do you know a predictor is a good predictor? Usually there are 2 criteria. One, this predictor highly related to dependent variable y. Oh, by the way, predictor, we also call independent variable. So x is a predictor and y is dependent variable. We also call criteria. Okay. So what is a good predictor? There are 2 characteristics. One, it will contribute a lot to y. 2, this predictor will not relate to other predictors. Okay. So this is question 1. Question 2, what are the assumptions associated with multiple regression? Okay. The assumptions is the variable y will be normally distributed. Okay. The variance of y is constant. The residues are independent. Okay, residues are independent. And also it has a linear relationship. Okay, x and y has linear relationship, linear. So those are the assumptions of multiple regression. Question 3, what does the partial regression coefficient measure in multiple regression? Okay. The partial coefficient measure, let me give you an example. Measure the average change in dependent variable in the relevant of independent variable, holding other independent variable constant. Okay, that is the partial coefficient. Okay.
Sorry, Professor, could you please repeat that?
Sorry, type it. What is your question? Repeat this answer. Okay, so partial coefficient. It is the coefficient between one independent variable and y holding other independent variable constant. For example, if I have x1, x2, x3, so the partial coefficient is holding x2, x3 constant. What is the coefficient between x1 and y? Okay, so that is the partial coefficient. Okay. So question 4, what does the standard error of estimate measure in multiple regression? It is just the standard deviation of y. Measure the standard deviation of y. So standard error of estimate measure standard deviation of y. So that is some concept questions. All right, so that's all for today. We have lots of time left. I would strongly suggest that you go over all the examples presented today to see if you can come up with the solution by yourself without looking at the solution for the examples. Okay. Any questions? Do you want to go over an exercise from textbook? Maybe some questions. Let me see. Do I have the time, the amount item? Do I have? This data is based on T9. Not here. Okay, any questions? Any questions? Okay, I will stop recording. If you don't have question, the lecture ends. If you have questions, you are welcome to stay to ask any questions you may have. Okay, so I'm going to stop recording. Initially, when this is virtual class, people do not suggest 3 hours. Most people, instructors, suggest just use 2 hours. Okay, in the previous weeks, we probably use 2 hour and a half. So today it is less than 2 hours. So if we average out, maybe 2 hours per week. Okay. So I'm going to stop recording.